The summer of 1783 began without warning, but within weeks, the air itself had changed. Across vast stretches of the North Atlantic and deep into Europe, a strange haze settled over the land. It dimmed the sun, stung the eyes, and carried with it an unfamiliar, acrid smell. Crops withered under a sky that no longer behaved as expected. Livestock weakened. People fell ill without understanding why. There were no distant explosions heard, no immediate signs of catastrophe for most who suffered its consequences. Yet far to the northwest, in the remote landscapes of Iceland, the ground had opened, and from it emerged one of the most consequential volcanic events in recorded history. The eruption of the Laki volcano was not a single, towering explosion, but a prolonged and relentless outpouring of lava and gas. Beginning in June 1783, a fissure approximately 27 kilometers long split open in southern Iceland. From this fracture in the earth, fountains of molten rock surged skyward, feeding vast rivers of lava that spread across the landscape. Over the following 8 months, the eruption would release an estimated 14 cubic kilometers of basaltic lava, covering fields, farms, and grazing lands. Yet the lava, destructive as it was locally, would not be the eruption's most far-reaching impact. The true devastation came from the gas's immense quantities of sulfur dioxide and other toxic compounds injected into the atmosphere. These emissions formed a dense volcanic haze, later described in Europe as a dry fog, which spread far beyond Iceland's shores. To understand the significance of Laki, it is important to consider Iceland's geological position. The island sits atop the mid-Atlantic ridge, where tectonic plates slowly drift apart. This setting makes Iceland one of the most volcanically active regions in the world. Eruptions were not uncommon in the 18th century, and Icelanders were accustomed to living with geological instability. However, the scale of Laki was unprecedented within living memory. As lava advanced across southern Iceland, it destroyed farms and pastureland critical to survival. Rivers were poisoned by volcanic runoff, and ash contaminated the soil. But it was the atmospheric pollution that proved most devastating. The release of fluorine-rich ash settled onto grazing land, contaminating vegetation. Livestock that consumed it suffered from fluorosis, a condition that damaged bones and teeth and ultimately led to death. Within months, the majority of Iceland's cattle, sheep, and horses perished. The loss of livestock meant the collapse of the island's food system. Grain imports were limited, and fishing alone could not sustain the population. Famine followed, and with it came widespread disease. It is estimated that roughly a quarter of Iceland's population died during what became known as the mist hardships. While Iceland endured immediate and visible devastation, the wider world experienced something more subtle but equally disruptive. The volcanic gases released by Laki entered the upper atmosphere, where they reacted with moisture to form sulfate aerosols. These particles spread across the northern hemisphere, altering weather patterns and reducing the amount of sunlight reaching the surface. By late June 1783, reports began emerging from across Europe of an unusual atmospheric condition. In France, observers described a persistent haze that obscured the sun, turning it a reddish hue even at midday. In England, the air was described as thick and oppressive, with a noticeable sulfurous odor. Similar accounts came from Germany, Italy, and beyond. The haze was not merely a visual phenomenon. It had measurable health effects. Contemporary records indicate increased reports of respiratory distress, eye irritation, and general malaise. Mortality rates rose in several regions during the summer of 1783, particularly among vulnerable populations. While medical understanding at the time was limited, modern research suggests that inhalation of sulfur dioxide and fine particulate matter likely contributed to these outcomes. Agriculture across Europe also suffered. The haze reduced solar radiation, disrupting plant growth during a critical period of the growing season. In some areas, Crops failed or yielded significantly less than expected. The following winter, 1783-1784, brought extreme cold conditions to parts of Europe and North America, possibly linked to the atmospheric effects of the eruption. In France, the consequences were especially severe. The country was already facing economic strain and structural inequalities in food distribution. Poor harvests exacerbated these conditions, contributing to rising bread prices and food shortages. While the eruption itself was not the sole cause of the social unrest that would culminate in the French Revolution later in the decade, it formed part of a broader pattern of environmental and economic stress. The reach of Laki's impact extended even further. In North America, the winter of 1783-1784 was notably harsh. Rivers froze for extended periods, and unusual weather patterns were recorded across the eastern United States. Though the connection was not understood at the time, these anomalies are now linked to the atmospheric changes triggered by the eruption. Back in Iceland, the eruption continued intermittently through early 1784. Each new phase released additional gases and lava, prolonging the crisis. Communities that had survived the initial months faced ongoing hardship, with limited resources and no immediate relief. Denmark, which governed Iceland at the time, struggled to provide effective aid due to distance and logistical constraints. The scale of the disaster gradually became clearer in the years that followed. Observers and scientists began to document the unusual atmospheric conditions of 1783, noting similarities across distant regions. However, the mechanisms behind these effects remained poorly understood until much later, when advances in atmospheric science and volcanology provided new insights. Today, the eruption of Laki is recognized as one of the most significant volcanic events of the last millennium, not only for its local destruction, but for its global consequences. It demonstrated that volcanic activity, even in remote regions, could influence climate, agriculture, and human health across continents. The event also contributed to the early development of scientific inquiry into atmospheric phenomena. Observations made during and after the eruption helped lay the groundwork for understanding the relationship between volcanic emissions and climate variability. This knowledge has since become essential in assessing the potential impacts of future eruptions. In retrospect, Laki serves as a reminder of the interconnectedness of natural systems and human societies. An event that began as a geological rupture in a sparsely populated region ultimately affected millions of people across the Northern Hemisphere. Its consequences were not immediate for most, but they were persistent and far-reaching, unfolding over months and years rather than days. The eruption did not produce a single defining moment of destruction visible to the world. Instead, it altered the environment in ways that were gradual yet profound. The skies dimmed, the air changed, and the balance of climate shifted just enough to disrupt established patterns of life. For those who lived through it, the causes were often unclear. The haze appeared without explanation, and its effects were attributed to a range of theories, from unusual weather to broader environmental changes. It would take generations before the link between Iceland's volcanic activity and Europe's atmospheric conditions was fully understood. In the centuries since, Laki has become a case study in the global impact of volcanic eruptions. It highlights the importance of monitoring volcanic activity and understanding the potential consequences of large-scale emissions. Modern technology now allows for more accurate tracking of eruptions and their atmospheric effects, offering opportunities for early warning and mitigation. Yet the fundamental lesson remains unchanged. Natural events, even those occurring far from major population centers, can have widespread and lasting effects. The eruption of Laki reshaped environments, influenced economies, and affected the course of human lives across continents. As the haze eventually dissipated and the skies returned to their familiar clarity, the world moved forward. Crops were replanted, communities rebuilt, and the memory of that strange, dim summer gradually faded. The imprint of 1783 endured in records, observations, and the subtle shifts it introduced into history. The story of Laki is not one of sudden catastrophe alone, but of slow, unfolding consequence. It is a reminder that some of the most significant events are not those that announce themselves with a single moment of impact, but those that quietly alter the conditions of life over time, leaving behind a legacy that extends far beyond their point of origin.